My name is Savannah Mead, and I'm conducting plant science research under the mentorship of Dr. Nicole Waterland at WVU. My research is about the performance of petunias with a hormone mutation that confers insensitivity to the plant hormone ethylene. This mutation, called the etr1-1 mutation, affects many different aspects of growth and development in petunias, and so I'm studying the differences in performance between etr1-1 and normal wild-type petunias. This research is really important to the ornamental floriculture production industry because petunias are some of the most popular ornamental crops and bring in a lot of revenue for producers. Any way to improve how petunias grow could provide immense economic benefit. If etr1-1 petunias create a better performing product with fewer inputs, then it could really be a game changer for the industry. Beyond that, the implications of this research can affect anyone that buys flowers for gardening because this could make the product longer lasting. Horticultural performance is a pretty broad topic to research, so I broke it up into metrics for defining it. Horticultural performance, generally speaking, is how well a plant grows according to the needs of the producer. For example, floriculture crops should have large, long-lasting flowers. I decided to look at mineral content of plant tissue, biomass, plant turgidity, and growth index, which measures vigor, as all of my metrics for performance. Because this is a 2-year project for me, I'm also going to be looking at stomatal conductance and rate of photosynthesis in the future, as well as exploring impacts of the mutation on tolerance to drought stress. Biomass is an indicator of growth and plant size, and the only statistical difference was a higher fresh weight in wild-type petunias. Along with that, growth index measures plant vigor, which is the rate and volume of growth. The growth index of the wild-type petunias was 43% more than the etr1-1 petunias, as you can see in figures 1 and 2. Though they were planted at the same time, the wild-type petunias tend to grow faster. However, increased biomass and vigor isn't necessarily desirable in the ornamental industry, where dense, bushy, and compact plants are actually preferred over elongated or leggy plants. Turgidity was measured by submerging cut leaves in water for 24 hours and seeing the change in weight as water was taken up by the plant to reach full saturation. The change in turgidity for both lines of petunias was not statistically significant, indicating little to no alteration in water uptake mechanisms. Mineral nutrient content influences most growth and developmental processes in plants. 11 mineral nutrients were measured. Samples were taken from both mature leaves and young leaves of all plants to gain a comprehensive profile of mineral nutrient content, since some nutrients are more mobile than others. Potassium and copper showed no significant differences between the wild-type and etr1-1 petunias, which indicates that formation, uptake, and movement of these nutrients is not impacted by insensitivity to ethylene. Potassium and copper are both important in carbohydrate metabolism and water efficiency with plants, which was not significantly altered as seen by similar turgidity. Phosphorus, sulfur, and manganese, which are important for flowering, ATP, and protein production, and increased water efficiency, were significantly higher in etr1-1 plants. Zinc was also higher in etr1-1 plants, though concentrations of this mineral are minute enough that interactions with ethylene and effects on performance are minimal within normal amounts. Iron and boron were both lower in etr1-1 plants, but slightly higher in young tissue compared to mature leaves. These minerals are immobile in plants, and deficiency symptoms appear on young leaves first, where they're normally abundant. The lower iron concentration in etr1-1 plants may contribute slower chlorophyll synthesis and could potentially reduce cell wall stability. Although these two minerals are lower, they're not deficient. None of the plants actually displayed any nutrient deficiency or toxicity symptoms. Calcium, magnesium, and sodium were lower in etr1-1 plants and also lower in young tissue. Calcium and magnesium interact closely with ethylene to induce fruit set and ripening, and so their low concentration in etr1-1 plants makes complete sense. Sodium tends to be higher in plants with lower phosphorus. The etr1-1 plants had elevated phosphorus levels, which is the likely reason for lower sodium. Concentrations of these three minerals are typical of an ethylene-insensitive plant and don't further affect growth beyond the mutation itself. As of right now, results indicate increased floral longevity, reduced vigor, similar turgidity, and improved aesthetics in etr1-1 petunias, which have excellent potential for commercial production compared to wild-type petunias. Mineral nutrient data supports these results, but also shows some qualities like potentially decreased biotic and abiotic stress tolerance that reduce the horticultural performance of the ethylene-insensitive petunias. Overall, the etr1-1 petunias have enormous potential for economic benefit to the floriculture industry, and with further research we will show the advantage of etr1-1 petunias used commercially. Thank you so much to the SURE program and Dr. Waterland for helping me. Thank you.